Here's a video about the change of base formula. Now let's imagine that you have a logarithm with a base that you don't particularly like, log base a of b. And it's hard for you to work with base a. That's actually equal to log base c of b over log base c of a for any positive value c that you like. Now, realistically, you could pick c to be any positive value, but most of the time you'll pick it to be something that you can plug into your calculator conveniently. So let's say log base 10, which we write just log. So log base a of b is equal to log b over log a. Notice the top number goes up, bottom number goes down. That's something you can plug into your calculator easily. Or you could say natural log of b over natural log of a. And just for kicks, you might plug in, pick a b and an a, and see that these are actually the same value. Now, so why would that be true? Let's just take a quick moment and ask, why would this equation be true? Well, let's take something like this, log base a of b, that's supposed to be a number x, and let's go back to what this actually means in terms of exponents. So if that's what x is, then a to the x equals b, right? And so if you had this equation, you wanted to write it in terms of logarithms with base c, you'd take log base c of both sides, log base c of a to the x equals log base c of b. Here, you'd have an exponent that would move out in front. So x log base c of a equals log base c of b. Divide by log base c of a, that's just a number. So x equals log base c of a over log base c of b. In other words, this equals that, since they're both x. That's where the equation comes from. Okay, let's actually use that to solve a couple of problems. Okay, so functionally, 2 to some power is equal to 5. How do you figure out what that x value is? You know it's bigger than 2, right? 2 squared is 4. Smaller than 3, 2 to the third is 8. How do I figure out what it is? Well, we convert it to a log equation. Log base 2 of 5 equals x. That's hard to plug into my calculator. If I'm trying to approximate it, what I'll do is I'll write natural log of 5 over natural log of 2 equals x. Then I'll approximate that value. 2.321 is the value. Next, let's look at this problem. Find the time required below. So this is a compound interest problem. Notice if you're interpreting this, you would be getting 14% interest compounded annually. And the question is, how long would that take $500 to become $10,000? Remember the compound interest formulas. Okay, how do I solve this? Well, first off, this is not a basic exponential equation, so I can't convert it to a log equation yet. I first have to divide both sides by 500. Luckily, that cancels a couple of zeros, so I get 20 equals 1.14 to the t. I convert that to a log equation. Log base 1.14 of 20 equals t. But this is something that I can't compute on my calculator easily while using the change of base formula. This is something that's really easy to calculate and comes out to approximately 22.863. So that's how you use that change of base formula to do actual problems.